When one thinks of medical research, the instant image that flashes to our mind is that of highly qualified scientists working on hot research topics such as cancer and AIDS. Although research into these topics is really important, there are other topics which are not as fancy and don't draw the same level of attention and are usually called as neglected or tropical diseases. Most of these diseases are prevalent in the third world countries where there is a great lack of medicinal facilities which further increases their severity. My research is on one such tropical disease called malaria, which is caused by Plasmodium parasites and is transmitted by mosquitoes. When I tell people that I am working on malaria, the first reaction I get is, don't we already have medicines for malaria? So if that's your question, then let me tell you, yes, we do have medicines for malaria. But the malarial parasites are increasingly growing resistant to them, and therefore there's an urgent need for new drugs. So how urgent is this need? The World Health Organization estimates that around the world, one child dies every 4 seconds due to malaria. So yes, we do need new drugs and we need them now. It turns out that movement is really important for the parasites to survive, and if this movement is stopped, the parasites can no longer invade cells, multiply or cause infection and will eventually die. The aim of my PhD is to stop the movement of the parasites, and I will be doing this by inhibiting a protein called actin, which is a key protein responsible for the parasite's movement. Actin can be visualized like a lock, which allows the parasite to move only when it is open. So in order to arrest the parasite's movement, we need drugs or a key which can close this lock. Now, although many such keys are known, the catch here is that humans also have actin, and all these known keys, they work like master keys. They lock the parasite and the human actin. In other words, they are toxic to us. So my challenge here is to develop a specific key for the parasite's actin. For this, I will first carefully study the differences between the human and the parasite actin using computer-generated model, and then design and synthesize a parasite-specific compound. Lastly, this new compound would be biologically tested to ensure that it is completely safe and effective before being further developed into a potential drug candidate. This would mean that we will be stopping the malarial parasites from moving and not children from playing. Thank you.